Introduction. Hello everyone, this is Solar Arc, a team from China. Our team is composed of 3 school members: Southeast University, Xinjiang University, and ETH. Desertification has been called the cancer of the earth. It threatens the survival and development of 2/3 of the world's countries and regions, and 1/5 of its population. Our site is located in Jiangsu, the most serious desertification area in China, which is located in the geographical center of Asia and Europe, the farthest place in the world from the ocean. Has the second largest desert in the world, the Taklamakan Desert. Jiangsu is the most mysterious place in western China. It's the intersection of many famous religions, history, and culture in the world. It's named famous village of China history and culture, and the oldest existing Aiga village in Xinjiang. Sunshine is abundant. Heat is abundant, but extremely dry. Rainfall is scarce. Here are some pictures of Jiangsu. This is some industries, environment, culture, and animals in the desert. This design aims to provide a solution strategy for extreme desert climate conditions and an example of sustainable architecture in desert areas. To develop desert cities and the full use of desert resources, and to adopt a variety of building techniques to avoid the adverse effects of desert climate. Logo generated from extract natural texture of desert as building facade, which comes from blowout dune formed by wind erosion. After 90-degree rotation, the wave-shaped facade of the building is obtained, which can realize self-shading in summer and sufficient sunshine in winter, with both form and function. The goal of the design is to meet the requirements of the solar arc, like the camel, the shape of the desert. Architecture. The vineyards in the courtyard satisfy the local people's living habits. People can barbecue and enjoy the cool air. Mulberry and poplar are planted in the courtyard. They are the original local trees. Poplar has a good effect on resisting sandstorm. The luxuriant branches and leaves of mulberry can provide shade.
1, 2, 3, 4。
当你在穿山越岭的另一边，我在孤独的路上没有尽头，时常感觉你在耳后的呼吸，却未曾感觉你在心口的鼻息。
A. Attached building. B. Service center. C. Apartment. D. Public parking. E. Private car park. F. Playground area. The natural texture of the desert is extracted as the building facade. The facade is designed to keep the building simple while ensuring self-shading. Engineering. The main structure of the building adopts a steel pipe. Composite structure is used at its external interface to realize the heat, preservation, and protection, as well as the connection of complex south facade. And we choose the local rich raw soil as the building wall materials. This material is convenient, low cost, but its bending shear capacity is poor. The improved rammed earth wall has good practicality. In the field of heat preservation materials, we use the heat preservation board made of cotton straw, which is the local material. The electrical outlet layout of each room in the house. Layout of lighting in each room of the room. Layout of indoor water supply and drainage. Resilience. As for the elastic design of the building, we mainly consider the impact of earthquake, wind, and dust storm on the building, as well as the cleaning of PV panels. The frame member is a patented product developed by us for structural instability in earthquakes. Its strengthening effect on the structure has been demonstrated through many actual projects, and it has the characteristics of lightweight, high strength, and good stability. Primary risk that our building may face is the seismic risk. Although its possibility of occurrence is very remote, its consequence is devastating. Therefore, we conducted structure analysis to evaluate the building's ability to withstand and recover from seismic activity by the commercial FEM software SAP 2000. By building information model, we can coordinate architectural design with structure design. SAP 2000 can automatically calculate the seismic loads based on the input parameters. Similarly, We applied the seismic loads in X and Y direction, and their combination on the steel frame model respectively. The results showed that our structure is reliable and stable under seismic loads. Due to its unique geographical environment, northwest China is a sandstorm-prone area. The Kumtuk Desert near Tuyuku is a source of sandstorms. The layout of building is optimized according to the dominant wind direction of the whole year. Grassbar sand barrier is a method of windbreak, sand fixation, and water conservation. Local people use grass nets as windbreaks to deal with the desert invasion. On the one hand, it can make the ground rough, reduce wind force and wind erosion. On the other hand, it can return rainwater and increase the water content of sand layer, which is beneficial to the survival of sand-fixing plants. Wind is an important external factor that influences the building's performance. The wind load is applied along with all external columns of the frame in both X and Y directions. Furthermore, dead loads and live loads were also applied on the structure to simulate a normal occupied state of the building. The result indicated that the maximal stress along all beams and columns won't exceed the yield stress of the selected steel grade, weather and wind load in X and Y direction, separately or combined. In the desert environment, the dust absorbed on the surface of PV panels is easy to reduce the system efficiency or even cause failure. In order to maintain the operation of the system, we designed several cleaning and maintenance methods that are easy to operate manually. Energy performance. Due to RAM or rate software can't set the project location as a non-US town, we refer to Wendover in Utah, US for HERS index calculation. The climate of Wendover is similar to that of Tuapan. The building envelope and HVAC design meet the requirements of DOE Zero Energy Ready Home manufacturer requirements and local building codes. The annual capacity of photovoltaic system is calculated by the PV watts calculator. The HERS index of solar arc is 48 without PV and 47 with PV. In the design of renewable energy system, photovoltaic power generation technology is adopted in solar arc, and off-grid system is preferred. In the early stage of the scheme design, we determined the optimal inclination angle of PV panel from three aspects: the maximum capacity and the off-grid system, the prevention of sand and snow accumulation and the self-shading of the body, which was verified by software simulation. It can be seen that the undulating facade can achieve self-shading of the body on the summer solstice, while the maximum area of solar radiation can be obtained on the winter solstice. Using NREL's PV watts calculator, the power generation of photovoltaic cells at three different locations is calculated respectively. The PV system diagram is as follows. It is calculated that the average annual power generation of each unit is 66.79 MMBTU. The average daily power consumption is 95.89 MBTU, and the average daily net power generation is 55.62 MBTU. The goal of Energy Plus building is achieved. The surplus power can be stored in the battery. can also be used to charge electric motorcycles or cars and provide power for surrounding communities. Comfort. Through optimization of building orientation at Tuapan by using genetic algorithm, it is found that building orienting south is best. An east-west deflection within 25 degrees has little impact on daylighting throughout the year. Daylighting baselines of 2% daylighting factor and 300 LX illumination are developed. Each layer is simulated according to 4 typical days at noon and daylighting factor. On work plane at 0.75 m to guide architectural design scheme. Through the ventilation simulation based on dominant wind speed and direction whole year and transition season. Suggestions are provided for the architectural design scheme and the interior space layout. When outdoor wind speed is relatively small, based on the principle of thermal pressure ventilation, atrium drives the airflow in the surrounding rooms. After optimizing the indoor comfort from the perspective of design, air conditioning equipment is selected to further regulate the indoor temperature. Selection of equipment is preferred to use products certified by Energy Star. Indoor temperature is controlled in 18 to 25 degrees throughout the year. Finance. Tuyuku is mainly the primary industry and the tertiary industry, almost no secondary industry. The primary industry mainly animal husbandry and planting. The tertiary industry is mainly tourism. The local government in Xinjiang offers generous subsidies, roughly divided into 2 parts. For projects that meet green building standards, the first is the Housing Department for Green Building Star Standards subsidies. The second is the subsidy from the Municipal Construction Commission. The total cost distribution structure is shown in the pie chart, and the specific cost of each part is shown in the right table. Market potential. The huge energy consumption of buildings put great pressure on the environment. China's green energy-saving buildings are also growing rapidly year by year. The design accommodates the service laundry space, spacious kitchen space, and storage space. We also increase community supermarkets, community activity areas, and public parking lots. Operation. First, smart home system. Smart home provides a convenient way to integrate all complex functions and integrates the operation of the building into a platform. Second, tracking technology of building information management platform. Through the following way implementation component information tracking. Monitor and trace the whole process of the Internet of Things technology. Component classification system, component technology, component coding rules, and component lifecycle tracking technology based on coding rules. Third, prefabricated building information management platform. The information monitoring database of building components can be located conveniently, and the life cycle information of components can be obtained by scanning the QR code of a mobile phone. The system enables real-time monitoring of the entire life cycle of production, transportation, installation, use, maintenance and dismantling, and engineering management and design. Innovation. Energy-saving window. The flow pattern of airflow in winter and summer is as shown in the figure. There are 4 kinds of airflow. These are the structural drawings of windows. We pay great attention to the use of a cloud in this design. First, we made the design course a WeChat official account. Click the link to see it immediately. Second, we made IH file, making cloud text displays available on various electronic devices, which brought Solar Arc to the market and attracted more attention to solar buildings. In the second China International Solar Decathlon competition in 2018, we built a 200-square building rapidly in 20 days. The industrial assembly type fast building is also our major innovation advantage. Sublimation theme. We are in the same world and face the problem of desertification together. The Solar Arc is expensive, with one building, a group of buildings, and even the building tiled in the desert like a grid, which meets the wind conditions. Together with the shelter belt of ancillary houses and the grass grid technology between buildings to form the ecology. Solar Arc will march into the desert, harness the desert, and finally turn the desert into an oasis.